Today's digital world is made up of a diverse collection of electronic devices, such as mobile phones, netbooks, PDAs, digital cameras, satellite navigation systems. The list goes on. These devices can be applied to a wide range of uses, such as information retrieval and entertainment. And as we see the number of devices increasing, users are being overburdened by having to configure and reconfigure them. What if there existed a system that was able to learn the user's behavior, and instead of having to configure the devices and services every time they wanted to use them, this system was able to automatically provide the user with what they wanted, in a way they wanted, and at times they wanted? The PERSIST project team have developed a working prototype of such a system. Tom travels a lot for his job and normally prefers to hire a car when he's abroad. He's just finished his meeting and is on his way to the airport. Here we see Tom using the car sat-nav to find the route to the nearest petrol station so he can return the car back to the airport with a tank full of petrol. Tom has been at meetings abroad over the last number of weeks, and on this occasion is on another business trip. He's just finished his last meeting of the day and is making his way back to the airport to catch a flight home. However, on this occasion, when Tom gets into the rental car and turns on the sat-nav, the PERSIST system has learned that he will probably want to find a petrol station and then travel on to the airport. Additionally, when Tom reaches the petrol station, fills the car with petrol and starts the navigation system, he is automatically shown a route to the airport, where he will leave the car back with the rental company. This is only one example of how the PERSIST system can be integrated with legacy services to provide users with an enhanced quality of experience. Our next sequence shows the detail of how PERSIST actually learns the user's behavior. The user performs some action, for example, sets their required destination in the Navit service. This user action is captured by the User Interaction Monitor, UIM, and the user's current context is updated accordingly. The UIM also records this action as a historical user behavior which can be learned upon. A snapshot of the user's current context situation is added to the user action. The user action and accompanying context snapshot are then stored in the user's behavior history store in the context history database. The UIM then posts an event to alert other platform components that the user has performed a user action. Many different platform components listen for events indicating the user has performed some user action. User intent is one such component. Every time such an event is received, an internal counter is incremented. If the counter exceeds some threshold, a user intent discovery cycle is triggered. The user intent discovery subcomponent requests the learning management, LM, to learn a new user intent model of the user's behavior. The LM retrieves the user's behavior history from the context history database. The user's behavior history is then processed by a sequence learning algorithm to discover repeated patterns of behavior. Each sequence is a linear list of user actions representing some task, and a new user intent model is created from the discovered tasks. The LM returns the new user intent model to the user intent discovery subcomponent, where it is stored in the user's context database. When a user action occurs, as well as potentially triggering a user intent discovery cycle, it also potentially triggers a user intent prediction process, if a user intent model exists. When an event is received from the UIM, the user intent prediction subcomponent retrieves the latest user intent model from the user's context database. The prediction algorithm then passes the user intent model to identify the current task, if any, that the user is most likely performing, and identifies the next actions in the task to implement. Once the next action is identified, the user's current context is checked against the model to ensure that it is an appropriate situation to implement the action. For example, it's undesirable to implement the action unlock car unless the user is beside the car. Once the context situation is correct, the action is forwarded to the decision maker. where the input is compared against other inputs from preference management and any conflicts are resolved. The successful action is then forwarded to the decision implementer, which locates the current instance of the service. Once the correct service instance is located, the action is sent to the service, where it is implemented. The vision of PERSIST is of a personal smart space, which is associated with portable devices carried by the users and which moves around with them, providing them context-aware pervasiveness at all times and places. The personal smart space will cater for the needs of users, adapting to their preferences and learning new ones as these arise. For more information, please visit our website.